Hello, I'm Marek Marczykowski-Górecki from Invisible Things Lab, and I will give some status update about Linux Stubdomains. So I am a free and open source software enthusiast for a long time, CTO of Invisible Things Lab and project leader of qrexec. So, a bit of history about Linux Stubdomain. So in Qubes 1.0 we had only PV domains. So no QEMU, no device model, only PV. Everything was simple. Then in Qubes 2.0 in 2013, we had initial support for HVM domains, where QEMU was isolated in a stubdomain, a unique feature of Zen. At that time, it was MiniOS-based stubdomain with QEMU traditional, which is a fork or very old version of QEMU, especially changed to work inside MiniOS. It was small, but it was not really maintainable because it was already at that time quite old version of the QEMU, and it didn't get any better later. So in Qubes 4.0, we migrated most domains to PVH from PV, mostly to avoid PV memory management complexity. But this means we needed better HVM support, especially for PCI passthrough. So we used Linux-based stubdomain with QEMU upstream. This work was done most based on part of the implementation from OpenXT project. We also did upstream implementation of libxl changes to make it work with the libxl tool stack. And yeah, exactly. So the stubdomain support is included in libxl, but not the actual stubdomain. There is at that point there was a Qubes version of that in a Qubes repository. It has it works with mostly vanilla Zen, but it needs a bunch of auxiliary services that are Qubes specific. There is also OpenXT implementation of Linux stubdomain, which was not fully compatible with this libxl implementation at the time, but it was similar. And then 4 more years later, there is a repository with generic stubdomain version that is compatible with the upstream libxl version with no Qubes-specific parts. And there are patches on the mailing list that include that in GitLab CI. So it's actually tested to remain compatible. Okay. So what we actually expect from such stubdomain and why going this way? In Qubes, we'd like to reduce attack surface, which means we don't like running QEMU in DOM0, like at all. Theoretically, there are ways to sandbox QEMU in DOM0. You can do a QEMU deprivilegation with using different user, maybe some extra sandboxing, seccomp, BPF, etc. But DOM0 is a PV domain, and for performance reasons, a lot of speculative mitigations are disabled in DOM0, so it's still not perfect. And also, Linux sandboxing mechanisms are not bad, but also they are not perfect. That's why we don't consider containers as a security boundary. So this is not something we'd like to use. But on the other hand, we need that QEMU for HVM guests, especially to get PCI pass-through. PCI pass-through for PVH guest is hopefully going to happen at some point, hopefully sooner than later, but until then, we need something. And also, when going with some separate subdomain for HVM, we can also use it for some extra stuff. We have in Cube-specific GUI protocol for extracting individual windows from VMs. We can use that instead of standard VNC to view the screen VGA output. And also, having that in place, we can also provide some services like DHCP server to run it in isolated sandbox instead of some common VM for all the guests. Okay, so how it's done? We have Dracut base build. Dracut is a tool to build InitramFS on Red Hat systems. The convenient thing is it has a tool to pick up a binary with all required libraries. So we pick up host binaries and copy them with all the required libraries. We have some optimizations there. For example, we do a custom build of QEMU. We don't use the one built for the host. We do custom build with very minimal configuration with many things disabled. I think we even have some patches to like comment out some parts that are not needed in subdomain to avoid extra dependencies, because size is a concern here a bit. The bigger the subdomain is, the more extra memory for every HVM guest you need. And this is combined with also minimal build of Linux kernel, some recent version of QEMU. Okay, it's maybe not that recent, but it's due to using directly upstream version, it's very easy to update. And also we have custom build of BusyBox to provide some shell for scripting and some auxiliary tools like the DHCP server. Okay, so that's how the base building blocks. So having that, and this whole thing is built into InitramFS. So it's a kernel plus InitramFS. There is no root file system on a disk image for a subdomain itself. Okay, so having that, we can add some extra stuff. For example, in Cubes, we'd like for HVMs to be able to play some audio or maybe record some audio. Normally, for Cubes VMs, we use custom pulseaudio or pipewire plugin that is basically PV audio. But for HVM guests, we could do that. There was some attempt, it's not completed, but there was some attempt to PV audio for Windows. But in HVM guest, you can run any operating system, and we don't really like to implement the drivers for every single operating system, but we can provide audio via QEMU emulated device, and in the run our pulseaudio plugin in a subdomain together with pulseaudio. It uses some more memory in the subdomain because we need to run a pulseaudio. We also do a very minimal build of that pulseaudio, but it's possible. And it was quite easy to implement, so why not? For that, we need some minimal parameters like the model of the audio card to emulate and the backend domain ID to connect to. So we use QEMU command line for that, and there is an init script in some Stubdomain that filters out what parameters are to be used for launching pulseaudio, and use all the other parameters to QEMU. So it's like they are mixed, but there is a script that separates them. And since very recently, we also allow dynamic switching between different backend domains. So it works like this. We have a QEMU in Stubdomain talking to pulseaudio, but then we have this pulseaudio can switch between backend in DOM0 and backend in sysaudio or whatever other VMs can provide a backend. This is very useful if you use some USB audio headphones, some Bluetooth or whatever, so you can switch dynamically. And we, for the signaling when to switch and where, we use qrexec, which is another kube-specific part. So it's basically RPC mechanism. Yeah. Another part that was a bit of challenge is direct kernel boot. When you run QEMU in DOM0, you can tell QEMU to load kernel from some specific file. Okay, but if you run QEMU in Stubdomain, you don't have access to DOM0 file system to load that file. So the solution we currently use in Cubes is we have one of the PV disk reserved for this purpose, XVDD. I think that's, yeah, I hope that's correct. And we have...
Your running system.
Hmm?
You could check your own system.
Yeah, yeah. So that's PV disk reserved to. Hmm?
1 second, sorry.
Hmm?
Microphone's about to die.
Oh, sorry. Thank you. Okay, so we have an extra PV disk to have the kernel file, intramfs file maybe for the guest to run, and also for module for matching to this kernel for the DOM to mount. Because remember the PV disks are exactly the same for Stubdomain and the actual DOM. This is how Stubdomain provides emulated disk images. So the PV disks are connected to Stubdomain, and then QEMU connect to them to emulate those devices to DOM. But we can reuse one of those to also, in addition to modules, to also provide the kernel image. And we mount it read-only in Stubdomain and read the kernel image from there. This is a bit of a hack. That's not going to work upstream because we cannot reserve specific PV disk. Like, okay, if you use Stubdomain, you cannot use XVDD for anything else. That's not going to work. But it does work for cubes. And there was a funny thing that we still want to provide some kernel parameters to that kernel. We do that using standard libxl option. It's extra option in the config. But if you try to do that without providing a kernel option, which we don't do using this trick, libxl complains that we provide some kernel parameters without actual kernel. So we have a patch that disables this check. Okay. So what else we can do? We can do USB passthrough. This is probably not a very common solution, but we use USB IP for USB passthrough. Back when we implemented USB passthrough in Cubes, we did tests of several solutions. We did PVUSB. It was not in upstream Linux at that time, but we tested the drivers. We tested I think we also tested the drivers from OpenXT project, and I think there was 3 or 4 different drivers we, generally PVI, USB pass-through solutions we tested, and the thing that worked best was USB IP. And there is IP in the name, but it's a lie. From the kernel point of view, USB IP expects a file descriptor from user space. Normal tool stack for USB IP connects, opens a TCP connection, TCP socket, and connects it to the kernel. But we can use something else. We use our qrexec mechanism, which is the RPC between, it's basically socket-like connection between VMs. It's a wrapper over vchan, which is currently in upstream library. And this works quite well for PV, PVH domains, and HVM with Qubes tools inside in PV drivers. But if you don't have Qubes tools inside the HVM, we can also use the stubdomain to emulate the device. So we use the same trick as with pulseaudio and audio pass-through. We connect what normally would be connected directly to the guest. We connect it to stubdomain using this qrexec. We had qrexec already. I mentioned it in for the audio switch. So we do that, and then we have mdev, which is very small UDEF alternative. We have a script that detects if new USB device appears, then talks to QEMU to attach it to the guest using QMP. In this case, libxl is totally unaware of any USB devices. That works for our case. I guess if somebody tries to use both, libxl may get confused what this USB device is, but we don't use USB pass-through in libxl, so it works. This is another part that is not currently, that is not upstream, especially because the different technology for USB pass-through. But I guess something similar could be also used using PVUSB to stubdomain. The downside is that PVUSB has a backend in QEMU, which in Qubes we don't like to have in DOM0, and I'm not sure if it supports driver domains. Well, whatever. Okay. So next challenge is PCI pass-through. The main reason for using stubdomains and HVMs for us was to get PCI pass-through when we migrated from PV to PVH. We couldn't use PVH with PCI pass-through, so we used HVM, but we needed something for PCI pass-through. Generally, PCI pass-through worked quite well with stubdomain. We needed few changes for config-based access because stubdomain has also PCI device attached as using PCI front-end backend. This is used by QEMU for config-based access. But the problem was with MSI-X, because QEMU would like to use devmem for some operations with MSI-X, and devmem in stubdomain is not really the host memory as it would be in DOM0. So it didn't work. Our initial implementation simply disabled MSI-X. We had a QEMU patch that removed it from PCI capabilities. But later, we worked quite a bit to fix also MSI-X support. So this requires two changes. One is that Zen pass through only some writes to MSI-X table to device model. there was some optimization, but this optimization was actually harmful because QEMU didn't get a full picture of the actual MSI-X state, so it accessed the defmem to get the actual content. So we changed that in Zen. The patches are in 4.19 committed already. So that's one thing, and the other is PBA pending big bits array, if I remember correctly. Access, it was also something that Zen didn't allow to read if it was on the same page as MSI-X table. So QEMU used defmem to read that. So we also changed Zen to allow guests to read this area, and we could get rid of QEMU opening defmem at all. There is so the patch changes to Zen are committed. Patches to QEMU to actually use this change are posted. I think they got a review, but they were at the time they were posted. There was code freeze, and they are waiting for to be committed. And we used it in Qubes 4.2 quite successfully. Okay, there is one thing we did implement in Linux Stubdomain initially. Is safe restore. It's used also for live migration. We don't use that in QubesOS, so I'm not sure if it still works because we don't use it. In the initial implementation in 2018, it did work. I did some tests when upstreaming the libxl work, but there are probably some of the way we did it could be done better. For example, we needed to patch Zen console D to support more consoles because we use console for data transfer, and if you connect more than one console to a guest, in this case, Stubdomain, upstream QEMUs force you to use QEMU instead DOM0, which we don't like. So we had a patch for Zen console D, and it wasn't really liked by maintainers. Yeah. So what's the upstream state of this work? The libxl support is upstream for a long time. Stubdomain current repository, the implementation, the Qubes version is working in production for a long time, but there is a branch stripped from all the Qube-specific parts with everything that is just for upstream libxl. It is limited. It doesn't have this audio USB, doesn't have the video access, but it works. There is a branch. It's going to be moved to GitLab, then a project organization. I need to clean up Git history a bit or something. And I also posted a GitLab CI series that test if that really works. And there are 2 or 3 maybe even more, tests for different scenarios with PCI pass-through, with CD-ROM booting, and stuff like that. So, yeah, it works. And there are some, work points to do. Quite recently, somebody posted an idea to implement VNC access via vchan. So there would be a vchan proxy into Stubdomain that connects to QEMU to access a VNC. I think it's quite easy to add, and would make it much more useful outside of Qubes. So maybe. And direct kernel boot is waiting for some solution that would work upstream. So I have some links. The slides are uploaded already. So if you want to learn more here. And are there any questions? Yep.
For direct kernel boot, could you use a vchan to write the file into the stubdom in RAMFS and then have QEMU read that?
Maybe. Yeah, that's one of the options that could be considered. Yes, considered. Yep. Yeah.
What kind of memory footprint are we talking about?
Yeah, currently the subdomain is using 128 megabytes, I think. It's quite a lot compared to MiniOS subdomain, which used 32, I think. I would be really happy if Unicraft could be used for upstream subdomain, but I'm not sure if that's the case already. So I hope to learn this on some design session. Yeah. And if you need, if you add this USB and pulseaudio, I think you need 150 megabytes, something like that.
What do you use to debug this subdomain if something goes wrong?
So there is a console for logs. So all the messages are extracted. And if I really need to debug some QEMU crash or something, I built a bigger image with GDB inside subdomain. So it needs a lot more RAM, but for debugging it's fine.
Do you have a way to capture core dump or something without
Not,
preparing?
no, without custom build, no. Not right now. Okay, I think we are out of time for.
What models do you rely on in QEMU? I imagine you don't need every single device that it provides.
No, I need only emulated disk, VGA, I don't remember which one, and USB for USB passthrough, and USB tablet, mouse, and yeah, input devices. I think that's all. Yeah. Yeah, and of course the whole machine. Like we use the old PC one, not Q35, because it's not working with that yet. Yeah. Yeah. Thank you.